Hey everybody, this is Mr. Stevenson here. I'm going to go over this group quiz number 3 so you can see how to do each problem. Feel free to skip around so you can get to the problem you need. And again, just keep in mind that as I solve these, this is just one way. There's always like many different ways to solve these problems, but I can't go over them all at once. So let's start with number 1 here. It's asking us to solve each system by graphing. So what it means by system is that we have more than one equation. As you can see, there's 2 equations here, and when we're solving, what we're finding is a point of intersection. We're trying to figure out when are these 2 equations equal, which is the point of intersection. So if we're graphing, then when we're graphing lines, we like it. It's easy for us to graph if it's in this form: y equals mx plus b, which means we need to get y by itself. So let's look at this first equation, and we need to get y by itself, which means let's go ahead and add y to both sides. If we add y to both sides, we're going to have y plus x equals -1. And then from there, we can subtract x on both sides, and we will get y equals -x minus 1. All right, so that's for this first equation here. Let's go ahead and graph it. The y-intercept is -1, so on the y-axis we're going to plot -1, and then the slope here is -1 over 1, right? If you don't see that number, it's a -1 over 1, so we're going to go down 1 over 1, down 1 over 1, and continue that pattern like such. And so this line looks like that. Please use a straight edge for yours. There's no straight edge on this computer. So for the next one, which is y minus x equals 3, we need to add x to both sides so we can get y by itself. And that, I'll put that over here. That's going to be y equals x plus 3. So the y-intercept on this one is 3, and the slope is 1 over 1, right? You don't see it there, but it's 1. So we're going to go up 1 over 1, up 1 over 1, and we could also get some points down here by doing the opposite, like this. And so that's the graph, and the solution is this point of intersection right there, right? This is the solution, and it's at the point -2, 1. So that's the solution to that system when we did it by graphing. Okay, for number 2, we are trying to sketch the solution to the system of inequalities. This is very similar to the problem we just did. The difference here is that they're inequalities. The first thing we're going to do is we're going to graph the boundary, and we want to remember that if we see less than or greater than, then we're going to use a dashed line. If we see less than or equal to or greater than or equal to, we're going to use a solid line. Right, so we're starting at 3 because that's the y-intercept, and we have a slope of -1, so it's down 1 over 1, down 1 over 1 like this. And because this symbol here is just less than, there's no or equal to bar, this is going to be a dashed boundary, right? Which means we do not include the points on the line. And then the next thing we need to do is we need to decide which side do I shade on. So here, to do this, there's several ways. You can see that it's a less than symbol, which means you shade below, right? So if I ever see less than or equal to, that means we're going to shade below. And if I see greater than or equal to, that means we're going to shade above. But a better way to do this would be to actually check a point, right? So let's check 0, 0. What that means, we're just going to plug in 0, 0 to our equation here, and if we do that, we get 0 is less than 3, right? I'm plugging in 0 for y and 0 for x, and we get 0 is less than 3, and that is true. So here's the point 0, 0. Because that point is true, it should be in my solution space, which is all of this stuff down here, which is below the line, right? It has the less than symbol, so it's below the line, so we're getting that same thing 2 different ways. Okay, and now for the red line, same idea. We're going to go to -3. That's the y-intercept, and this has a slope of 5. So from -3, we're going to go up 5. 1, 2, 3, 4, 5 over 1. That puts us there. That's really the only 2 points we can do. This one we see a greater than or equal to symbol, which means this is going to be a solid line. It looks like that. And then again, we could check 0, 0. If I plug in 0, 0, we're going to get 0 is greater than -3, which is true. So again, I want to shade on the side of -3, which is, or sorry, I want to shade on the side of 0, 0, which is here. So I'm shading all of that. And our solution region is this region here that is shaded both colors, right? So our solution region is this piece over here. And so the question up here asks us to identify one point that is a solution to the system. So I just need to pick any point that's in that region that's shaded both pink and green. So, you know, again, there's an infinite amount of answers here. Just pick any point over here. Let's just pick maybe that point right there, -3, 2. And then we want to identify one point that is not a solution, and this is just picking a point that's not in that dually shaded region. And I'm just going to pick a point. I'm going to pick a point down here just to emphasize that it can be in one of the shaded regions. It just can't be in both the shaded regions. And so 3, -2 is not a solution to the system. It's a solution to that first equation, but not the second one. Okay, so that's that one. Now we're solving systems algebraically. I mean, you could graph these if you wanted to, but you know, these ones are kind of set up. There's no graph given to you, so most likely we're going to solve them algebraically. Our options here are we could use elimination, which is nice when the variables are lined up. Like the variables are on top of each other, kind of like number 5. You see how the x's are on top of each other and the y's are on top of each other. That one lends itself to elimination. And there's also substitution, which is when you have like y equals something or you have x equals something, right? It's already solved for y or x. And so in this first problem, I see that this first equation is already solved for x, for y. So what I'm going to do is I'm going to take, I know that y is x plus 10. I'm going to substitute into the second equation. I'm going to replace y with x plus 10. So this is going to look like this, -5x minus 3. Instead of writing y, I'm going to write x plus 10, and the rest of the equation is still the way it was. Now notice that the only variable left is x, and so I can solve this equation for x using, you know, techniques that we've learned in the first few weeks of class. We're going to distribute this 3. Then we're going to combine like terms, right? -5x minus 3x is -8x. Then we're going to add 30 to both sides, which is going to give me 40 on this side. Then we're going to divide both sides by -8, which is going to give me -5. So x is -5. Just keep in mind that we are looking for a point of intersection. So notice what this solution looked like. It had an x coordinate and a y coordinate. So I need to make sure, you know, this is my x coordinate. My final solution is going to say -5, but then there needs to be a y coordinate. So I need to figure out what y is, which means I'm going to take my x value. I'm going to come back up to this equation, and I'm going to plug it in. I'm going to plug in my x value to figure out what y is. And so it turns out y here is 5. Right? And so the point of intersection is at -5, 5. Okay, so problem number 4 now. We're noticing, hopefully again, that this one is solved for y, right? Y is all by itself, so that lends itself to substitution again. So we're going to take this, what y is, and we're going to substitute it for y in the other equation. So we're going to get -6x minus, wherever y is, I'm going to go and put parentheses. And then inside those parentheses, I'm going to put the thing we're substituting in, which is that. Okay, now we're going to go about solving this, you know, the way we've been doing. We're going to distribute that negative. A negative times a negative is a positive, and a negative times a negative again is a positive. And so we get this. We're going to combine like terms. -6x plus 6x is 0x. So those things are gone, and we're just left with 4 equals 4. which notice you don't have a variable anymore, right? We just have 4 equals 4, which means what, right? Like, okay, what does that mean? Notice please that this is a true statement, which tells us what it means. But just to show you what's happening, let's just go back up to this and let's look at this bottom equation, right? Let's solve it. Let's put it in y equals mx plus b form real quick, just so you can see something. If we add 6x to both sides, I'm going to come over here and do this. If I add 6x to both sides, I will get negative y equals 6x plus 4. And then if I divide both sides by negative 1, right, this is like a negative 1 here, I'm trying to get y by itself, then I'll get y equals negative 6x minus 4. So I want you to look at that, negative 6x minus 4, and what this other equation is. It's also negative 6x minus 4. So these are actually the same line, which means when we're trying to find points of intersection, right, I would have like a red line like this, and then the other line would be right on top of it. And so the question is, well, where do they intersect? And the answer is they are always intersecting, right? So it's all real numbers is what your solution here is, right? There's infinite solutions. So the hint here is when you get this, when your variables cancel out and you're just left with this like true statement, then your answer is going to be all real numbers. Now, if it was a false statement, that would be a different case, which we'll look at in a little bit. Okay, on to number 5. Like I was talking about before, number 5 lends itself to elimination because the x variables are lined up, right? You can see the x's are on top of each other, the y's are on top of each other, and then all the other numbers are over here, right? So that means elimination is going to work out nicely for us. With elimination, we need to get the coefficients in the front of the variables, at least in front of one of the variables, to be the same number but opposite signs. And so you could choose to do that for the x's or the y's. I'm going to do the x's here, which means we're looking for a least common multiple. In this case, our least common multiple is going to be 15. And I'm going to multiply the top equation by 5, and I'll multiply the bottom equation by 3. Okay, so we'll multiply the top equation by 5. We're going to get 15x minus 20y equals negative 10, right? We're multiplying every term in there. Both sides of the equation are getting multiplied. Because we're multiplying both sides, we're really not changing that equation. We're just writing a different version of it. Okay, now the bottom equation, we're going to do 3 times negative 5, which is negative 15x. 3 times 5y is 15y. And 3 times negative 5 is negative 15. Okay, notice what happened, right? We multiplied by 5 and 3 so that we would get that situation, positive 15x and negative 15x. And the reason we want that is because we're going to add these equations straight down, right? We're going to do 15x minus 15x. Those things cancel, they eliminate, hence the name elimination. 20y plus 15y is negative 5y, and negative 10 minus 15 is negative 25. Notice all that's left is the y's, so we can go ahead and try to solve for y by dividing both sides by negative 5. If we divide both sides by negative 5, we're left with y equals 5, right? Negative 25 divided by negative 5 is just 5. And again, it's tempting to stop there and be like, yay, I'm done. But remember, we're looking for a point. We just found the y coordinate of that point. We need to find the x as well. So we take our answer and we go back to one of the original equations, or any of these equations up here really, and we're going to plug in 5. So we're going to do 3x minus 4 times 5. So I'm choosing this, this original equation here, the top one, and I'm going to plug in that 5 that I got for y right there, and solve for x. Figure out what x is. So we're getting that. We're going to add 20 to both sides, and we're going to get that. We're going to divide both sides by 3 and get 6. And so the x coordinate is 6, and our solution is 6, 5. That's where they would intersect, right? You could graph them. I encourage you to go on Desmos and just type those two equations in and notice that they intersect at 6, 5. Okay, number 6, same idea. Notice how the x's are lined up, the y's are lined up, the constants are lined up. This one lends itself to elimination. And again, the idea is want to multiply one or both equations so that the numbers in the front, the coefficients in the front, are the same. So I'm going to multiply, I'm going to look at the x's and I'm going to say, okay, well, the least common multiple there is 6. So I need to multiply the top equation by 3 to get 6. 3 times 2 is 6. And I need to multiply the bottom equation by 2 to get 6. And actually I want them to be opposite. So I'm going to multiply this bottom one by -2 so that I get -6. Alright, so top equation, 3 times 2 is 6x. Sorry. Okay, so 3 times 2x is 6x. 3 times 8y is 24y. And 3 times 2 is 6. That's the top equation. Bottom equation, -2 times 3x is -6x. -2 times 12x is -2 times 12y is -24y. And -2 times -3 is +6. Okay, so then we're going to go ahead and add straight down. 6x minus 6x is 0. 24y minus 24y is 0. 6 plus 6 is 12. So we get this statement 0 equals 12. And I want you to notice that unlike number 4 above here, this is a false statement. 0 does not equal 12, right? There's in no world is 0 the same as 12. And so what's happening here is if you graph both these lines, you might get like the red line is like this, something like that, and the green line might look something like this. And what's happening is they are actually parallel lines, right? If I could draw those straight, you'd see that they're parallel. And so again, the question is, where do they intersect? And the answer is, well, parallel lines don't intersect. And so this one, there is no solution because there's no points of intersection, right? Again, if I could draw this a little bit straighter, you'd see that, you know, if they're parallel, they're never going to intersect, and therefore there's no solution to this. All right. Let's go ahead and do the next ones. Okay, number 7, we're still on solving systems of equations. Again, there's a graph provided here, so you know, graphing is a good idea to solve this one. Now you could set these equal to each other and use the methods we learned earlier to solve algebraically, but let's do this one graphically because I think it's actually quite a bit easier. So first one, this is a line, right? There's no absolute values, nothing going on. This second one is a v because it's an absolute value. Okay, so the first one, it's already in y equals mx plus b. So you plot the y-intercept, and our slope is going to be up 2 over 3. Up 2 over 3. Get some in the other direction, down 2 over 3, down 2 over 3. And the reason I'm getting all these points is because I need to be really precise because I'm going to be finding points of intersection, right? So I need to be precise as precise as possible. And then for the next one, because it's an absolute value, this is that time when it's giving us the vertex and the slope. And so the vertex of this one is -3, 4, right? It's always the opposite of what you see inside the absolute values. And this 2 is the slope. So we're going to start at -3, 4. And keep in mind we're trying to create a V shape here, right? Either like a V or an upside down V. Which all V's have this line of symmetry that go right through the middle, right? And that line of symmetry goes through the vertex all the time. So my slope is -2, so from the vertex I'm going to go down 2 over 1, which puts me there, and I'm going to keep doing that, down 2 over 1, down 2 over 1, keep going, down 2 over 1, down 2 over 1, and down 2 over 1. And that's the right half of the V. Just remember the other half is symmetric, so it's just these same points but reflected across that yellow line, right? And so this one looks like that. And it wants us to solve it, which means we need to find these points of intersection, which are here. And they also occur down here where these two lines cross. And it's unfortunate that they're not crossing in the plane, because that's what I thought this was going to do. So let's go ahead and estimate this one. This one, you know, this is not perfect because we're graphing, but this one looks like it occurs at 0.6 or 5, you know, somewhere in there. And then the y-coordinates maybe -3.5, right? So we're estimating because we can't see it perfectly on the graph. This other one we could figure out pretty close what it is if we just continue this graph going down. This one, we're going down 2/3. So we go down 2/3, and then this one we're going down 2/1, down 2/1, down 2/1. So that would be -8, -9, -10. You know, maybe -11 as an x-coordinate, and then as a y-coordinate you got -8, -9, -10. Yeah, maybe -11 as a y-coordinate too if you're estimating. On the test you'd be able to see the points of intersection much easier, so don't worry too much about the preciseness of this, because it should just, you know, for the reasons of the test would actually be easier to see than this one. Number 8. First things first, identify the vertex. So the vertex is that point where it stops going down and starts going up. So in this case that point is -3, 2, right? That's the coordinates of that point. The axis of symmetry is that line that divides your V in half, right? It's this yellow thing that I'm doing here. It's a vertical line. It goes through -3, so it's the equation x equals -3. Now the equation for this, for the actual absolute value, is in this form, right? It's vertex form of an absolute value equation. The a is the slope, and the a is the slope. The h is the x coordinate of the vertex, and the k is the y coordinate of the vertex. And so let's go ahead and find the slope first. The slope of this one is find two good points, right? So the vertex is a good point and this one's a good point. So you're going up 3/2. So the slope is 3/2. The x coordinate of the vertex is -3, and the y coordinate of the vertex is 2. So now that we know that, we just take all that information and put it in our equation. Like such. And then, you know, there's some simplification required, right? We need to, you know, we don't want to write double negatives like that. Double negatives create positives, and there's, you know, the simplified version of that equation. So that's what we should write up here, right? Y equals 3/2 absolute value of x plus 3 plus 2. Okay, moving on. Graphing and describing transformations. Again, this is just like backwards what we just did. You're given the vertex and the slope, and so the vertex on this one is at 1, 2. The slope is 2, so we're going up 2/1, up 2/1, and these things have symmetry, right? So that line of symmetry goes right through the vertex, and so each of these red points is reflected across, and so this graph looks like that. It asks us to describe the transformations on the parent function. Just remember the parent function is that graph that goes through the origin, has a slope of 1. So we're just trying to describe how is this different, right? So our function is translated right 1 and up 3. Notice the slope also made it skinnier, but instead of saying skinnier, we're going to say there was a vertical stretch, which is another way of saying skinnier, by a factor of, and then the factor is simply just the slope, so by a factor of 2. Right, and that's the transformations on that one. All right, next one. tricks some people because they don't see like that H, and so you're just asking what number is being subtracted from X here, right? What's the H value here if I don't see it, if it's not even there? Well, that just means it was a 0, right? So the X coordinate of the vertex is 0, the Y coordinate of the vertex is -1, and the slope is -2. So we're going to 0, -1, right? And we're doing a slope of -2, which means we're going down 2 over 1, down 2, right 1. And then we're, knowing that these are symmetric, we're going to get the other side like this. And that's what that one looks like. Describe the transformations. Well, I got from that parent function, which again, the parent function is always the one that goes through 0, 0. From that parent function, this one was translated down. Actually, let's do this. Let's say reflected. You see how it's flipped over, so it's reflected over the x-axis. The reason I want to do that first is that actually has to happen first, and then you translate down 1. Because if you do the translate down 1 first and then reflect it, you actually end up in a different spot. So it was first reflected upside down, then it was translated down 1. And again, this one is skinnier than the original, so it's a vertical stretch by a factor of 2. Now let's just, because we had two of the same, if we had a graph that was somehow wider, right, like the slope was less, like let's pretend the slope was 1/2, then instead of saying vertical stretch, we would say vertical shrink by a factor of, again, whatever the slope is, so in this case 1/2. But the point I'm trying to make is if the graph was getting wider like this, or it could be up as well, right, it was wider in that direction, it's still a vertical shrink, and then by a factor of whatever the slope is. Okay, on to some word problems. The first thing we need to do, like I said in class, is change this. This should not be number, but it should be price of a senior ticket, and then price of a student ticket. So Amanda's school is selling tickets to a play. On the first day, they sold 1 senior ticket and 9 student tickets for a total of $128. And then they took in $94 on the second day by selling 5 senior citizen tickets and 3 student tickets. So the way this works is, if we want to know how much total money we make, what we do is we take the number of student tickets sold right, and we're going to multiply that times however much the cost is for a student ticket, right? And that'll tell you how much money you make from student tickets. And if I want to know how much money I make from senior tickets, I take the number of senior tickets and I multiply that by the cost of a senior ticket, right? The price of a senior ticket. So the dollar amount or price of a senior ticket. And if I add these two together, right, like this, like again, this thing is telling me like the amount of money I'm making from students, and this is telling me the amount of money I'm making from seniors. If I add those together, I get the total amount of money that I made, right? Because I'm adding the students plus the seniors. And so in our situation here, for this day one, we sell 1 student ticket, and we don't know what the price is. That's what we're trying to find out. So it's 1 times T, because that's what we're defining as a student ticket. And then we add that to, we're selling 9. No, I'm sorry, I got that backwards. We sold 9 student tickets. Right here it says 9 student tickets. So it's 9 times T plus we sold 1 senior ticket, and we made a total of $128. Right, that's the first day. On the second day, we sold 3 student tickets, right? That's right there, 3 student tickets. So that's going to be 3T plus we sold 5 senior tickets, and we made a total of, in this case, $94. Right? So those are the 2 equations. Now that I have this system set up, we can solve the system using the methods that we talked about before, substitution or elimination. And again, since the variables line up here, the t's are there, the s's are there, this kind of lends itself to elimination. So the first thing I'm going to do is I'm just going to go and write these equations down here, so that we have them together. And remember, with elimination, we're trying to multiply by something so that we have the same number but opposite signs. And so in this case, if I multiply the bottom equation by -3, then I'll have -9t, which will, add nicely with the other one. So let's multiply. We get -9t minus 15s equals -3 times 94, which is going to be -192. And then we take our other equation, right? It's just that top equation. I'm just rewriting it down here so I can see the addition really well. And we're just going to add these things together. So those cancel. Here we get -14s. And here we get -192 plus 128, which is -64. And we're going to divide both sides by 14. Oh, I messed this up. This is not 192. This is 292. My apologies. So 292 minus 128 is 164, -164. And -164 divided by 14 is... Hold on a second, I think I messed up a calculation here. Okay, yeah, I totally messed it up. This is 282. That's what I get for trying to do it in my head quickly on a video. And so that makes this 154. And then we divide by 14 and we get 11. So the value of S, the number of student tickets sold, was 11, and if I want to find the number of adult tickets sold, I just take that and plug it back into one of my originals. So it's going to be 9t plus that 11, right? I'm plugging into this equation, equals 128. So 9t equals 17, and so t equals 13, right? So the number of students was 13, the number of seniors was 11. And in this case, you don't really need to write it as a point. You're just giving 2 separate things, like the value of S is this, the value of T is that. Okay, I think 12 has a mistake on it as well, but we can just go with it and try to figure out what combination of coins might have actually worked. So we're digging in our pocket, we're pulling out 32 coins. They're all nickels and quarters, right? So you got nickels, you got quarters, and there's 32 of them, right? And somehow we know that it's $4.60. We're going to start by writing a system, and then we're going to try to use that to figure out how many nickels and quarters we have. So the first thing we're going to do is just go ahead and define variables. Let's let Q be the number of quarters, and let's N be the number of nickels. Then I can write 2 equations, one being I know that if I add N plus Q, if I take all my nickels plus all my quarters, I get 32. And the other one is I know that the value of a nickel is 5 cents. So if I take the value of the nickels plus the value of the quarters, which is 25 cents, then I'll get a total of $4.60. And now we're left with this. We're going to solve using whatever method we need to. I'm going to go ahead and use a substitution in this case. I'm going to solve that first equation for Q, right? So I'm subtracting n on both sides, and I get Q equals 32 minus n. Then I'm going to substitute that back in. So it's 0.05 n plus 0.25 times Q, which we figured out Q was 32 minus n. And then we're going to solve this, distribute 0.5 n plus a quarter of 32 is 8 minus 0.25 n equals 4.6. We're going to combine like terms. This is going to give us negative 0.2 n plus 8 equals 4.6. We're going to subtract 8 on both sides, and we're going to get negative 3.4. And then we're going to divide by negative 0.2. And we're going to get 17. Right, so that tells me the number of nickels was 17. And at that point, if I know how many nickels there are, well then I also know that there's 32 total coins. So 17 nickels plus however many quarters there are will give me 32. How many quarters do there have to be, right? There has to be 15 quarters, right? So the number of quarters is 15 quarters. 17 nickels, 15 quarters. Okay, last problem. The math club wants to buy some t-shirts to sell at a fundraiser, a fundraiser, I guess. They found 2 companies who sell their custom shirts at different rates. The rates are graphed below. And on your paper, it's given that this one is g of x and this one is f of x, and we're told that f of x is the cost of buying from Freedom Shirts and g of x is Great Shirts, right? So this is Freedom Shirts and this is Great Shirts. Not that that matters too much. The first question is, how many shirts would the cost of both companies be the same? So we're looking like at what point is the cost the same, right? So notice on the x-axis, this is the x-axis is the number of shirts, right? This is written on your paper, so I'm going to write it on here. This is the number of shirts, and over here is the cost of shirts. So for example, if I buy one shirt from Great Shirts, it costs me $15. If I buy one shirt from Freedom Shirts, it costs me $35. So at what point is the cost the same? And so that occurs right here at that point of intersection, right? Like they both, at that point, they both cost $55. Well, how many shirts is that? Well, it's when 5 shirts are sold, right? So 5 shirts cost the same at both companies, okay? So if I want to buy 7 shirts, which company would you use, right? So here's 7 shirts. The Freedom Shirts costs $65 and the Great Shirts cost $75, right? I'm just looking over here to get those numbers. Right, if I'm buying 7 shirts, Freedom Shirts cost $65, Great Shirts cost $75. Who are you going to buy from? You want to spend more money? I mean, I guess without knowing the quality, there's some other questions out there, but as far as money goes, we want to buy from Freedom Shirts, right? So we should say Freedom Shirts because they cost less. Next, we want to find f of 2. F of 2 is basically the function f of x evaluated at 2, right? So here's f of 2, and it equals 25, right? F of 2 equals 25. That's that 0.225. What it means is that the cost of 2 shirts at Freedom Shirts is $25. That's what f of 2 means, right? F of 2, sorry, I just did that on g, right? I just did g of 2. F of 2 is this one up here. F of 2 is is there, because that's Freedom Shirts, and that was 40. So we should say not 25, but 40. The cost of 2 shirts at Freedom Shirts is $40. It wants us to find f of 2 minus g of 2. F of 2 we just saw was $40. G of 2 is with that mistake I just made, which is $25, right? Again, you can go up to the graph and look at, okay, well, f of 2 is $25. And so 40 minus 25 is $15. What did we just find? Well, we just found the difference in cost from the two companies. Like how much of a difference is the cost between the two companies. When you buy 2 shirts, or if you buy 2 shirts, right? We're finding the difference in cost. Like one costs 40, one costs 25. And E is similar reasoning. We're going to find G of 5. G of 5 is $55, right? That's, if you look on the graph, we're just G of 5 is, we're looking at 5. Let me do this one in green. You can see it better. We're looking at 5. And then the value there is 55. And then the other one we're doing is G of 1. G of 1 is here. We're finding 35, right? G of 1 is this one. No, that's F. G of 1 is the one down here. G of 1 is this function. G of 1 equals $15. So 1 shirt costs $15. 5 shirts cost $55. What we're finding is the difference in cost between 5 shirts and 1 shirt. Another way of putting that is how much more does it cost to buy 5 shirts from Great Shirts than it does to cost 1 shirt to buy 1 shirt from Great Shirts, right? What's the difference in cost between those two? Okay, that's all the answers. I know the video is long. I hope it helps. Good luck on the quiz coming up. You can do it.